Something strange has been happening in our skies, and almost nobody was prepared for it. For months, astronomers expected September to be quiet, a routine stretch of space weather, nothing out of the ordinary. But instead, the heavens erupted in a wave of surprises. Asteroids seemed to appear one after another, comets brightened without warning, and a mysterious visitor from beyond our solar system suddenly streaked into view. It felt less like random chance, and more like a carefully timed performance, as though the cosmos had decided to put on a show, and we were caught in the front row without knowing why. At the center of this story is an object unlike anything we've seen before, a strange interstellar wanderer that doesn't belong to our sun, our planets, or even this corner of the galaxy. Scientists call it Three-Eye Atlas, the third interstellar object ever detected, following in the footsteps of ʻOumuamua and Borisov. But this new arrival is weirder, darker, and far more unpredictable. It carries with it a chemical makeup that defies expectations and behaviors no one fully understands. And it's not just passing through quietly. It showed up during a month when the solar system was already buzzing with unexpected asteroid flybys and fragile comets breaking apart, almost as if its arrival was part of something larger. What makes this so unsettling isn't just the raw science, though that alone is enough to rewrite textbooks. It's the timing, the patterns, the eerie way events seem to line up. Was it coincidence? A freak cluster of space debris? Or is this interstellar messenger a clue that our solar system isn't as calm and isolated as we once thought? Whatever the truth is, it's clear September 2025 wasn't an ordinary month for Earth. It was the beginning of a cosmic mystery that's still unfolding right now. September was never supposed to be like this. For years, astronomers had charted the orbits of thousands of near-Earth objects, carefully predicting their movements decades in advance. Most of the time, the sky behaves predictably. A rock hurtles past, calculations are made, warnings are issued if needed, and then the story is over. But September of 2025 shattered that sense of order. Instead of one or two expected flybys, the month turned into a cosmic storm, a rapid-fire sequence of discoveries that left scientists scrambling. Night after night, observatories reported new asteroids, new comets, new fragments appearing almost out of nowhere, as if the universe itself had decided to throw rocks at us all at once. The strangest part wasn't just the number of objects, it was the timing. These weren't neatly spread out over weeks and months the way random events usually are. They clustered, bunched together, sometimes overlapping within hours. The biggest headline came from an asteroid designated 2025 FA22, a dark rock that no one had paid much attention to until it crept unnervingly close to Earth. The measurements showed it wasn't the kind of rock that would wipe out humanity like the one that ended the age of dinosaurs, but its size was nothing to ignore either. If FA22 had hit, it could have leveled a city, triggered regional chaos, and left a scar that would be remembered for generations. Astronomers compared its potential impact energy to dozens of Hiroshima bombs, detonating at once. That kind of force isn't extinction level, but it's catastrophic enough to change lives, to shift economies, to remind us just how fragile our place in the cosmos really is. What made FA22 unforgettable wasn't simply the danger it posed, but the way it slipped into the narrative of September. Normally, the discovery of a rock like that would dominate the headlines for weeks, but here, it was just one beat in a larger rhythm, one wave in a rising tide. The fact that FA22 came so close at the same time as other objects were being spotted felt less like an isolated scare, and more like part of a bigger story unfolding in the dark above us. Scientists tried to explain it as coincidence, a trick of observational luck, but the public wasn't convinced. On forums, social media, and late-night podcasts, people whispered about patterns, about alignments, about whether something had disturbed the outer solar system and sent a swarm our way. The truth is that September had already been unsettling before FA22 brushed past. Comet Swan, a faint visitor thought to be just another icy traveler, suddenly brightened in ways no one predicted. Dusty tails flared, fragments began to break away, and telescopes captured images that looked almost chaotic, as though the comet was fighting to hold itself together. To casual skywatchers, Swan was just another pretty smear of light in the night. To professionals, it was a warning sign. Fragile comets often behave unpredictably, and a breakup event can scatter dangerous debris across Earth's orbital path. That meant Swan wasn't just a scientific curiosity, it was a potential threat, and it came at a time when the skies already seemed crowded with danger. But perhaps the most unsettling undercurrent of that September surge wasn't what we could see, but what it implied. Our detection systems, advanced as they've become, are still imperfect. The vast majority of small to medium asteroids go unnoticed until they're already close, sometimes only hours before they pass. The Chelyabinsk meteor in 2013, which exploded over Russia with the force of a small nuclear weapon, was never detected in advance. It came from a blind spot, hidden by the glare of the sun. September 2025 reminded us of that vulnerability on a much larger scale. If we were suddenly spotting so many objects at once, how many others had slipped past completely unnoticed? How many rocks were still out there, silent and invisible, just waiting for their turn to enter the spotlight? As the days of September dragged on, the discoveries piled higher. News outlets struggled to keep up. One day it was an asteroid the size of a football field cruising by at lunar distance. The next it was a smaller one passing even closer, closer than the moon, closer sometimes than our own satellites in orbit. Each time the message was the same: we're lucky, lucky it missed. Lucky it burned up in the atmosphere instead of reaching the ground. Lucky we had time to see it at all. But luck isn't a strategy, and the more this word appeared in reports, the more uneasy people became. You can rely on luck once or twice, but when a whole month seems to be gambling with cosmic dice, something feels wrong. Conspiracy theories erupted. Some claimed the government knew more than it was letting on, that military telescopes were tracking dozens more objects that were being hidden from the public. Others believed the clustering wasn't random, but orchestrated, the result of some massive disturbance at the edge of the solar system. Perhaps the mythical Planet 9, or even the gravitational wake of something stranger. There were even whispers tying these events to the newly discovered interstellar visitor 3Chi Atlas, as though it had dragged a train of debris behind it while crossing through the void. Scientists largely dismissed these ideas, pointing instead to chance, to improved detection methods, to statistical clustering that happens when you suddenly start paying closer attention. But deep down, even they couldn't ignore the strangeness of the month. For those who remember the asteroid Apophis, a rock once predicted to have a small but terrifying chance of hitting Earth in 2029, September brought back a kind of quiet dread. Apophis is still out there, still on course for a close pass, and while calculations now show it will miss, the public hasn't forgotten what it felt like to imagine a world staring down a true doomsday rock. The sudden surge of smaller objects was like a rehearsal, a reminder that our planet isn't as protected as we'd like to believe. It was proof that even without Apophis, the skies can deliver shock after shock, any day, any month, without warning. And yet, despite the fear, there was fascination too. Every night brought a new discovery, a new piece of news that made people look up. Telescopes became the hottest live streams online. Amateur astronomers shared blurry images, their excitement bubbling over with every update. Space agencies found themselves at the center of attention. Their cautious, scientific language turned into viral soundbites. 1 in a million chance, closer than the moon, potential city killer. These phrases spread like wildfire, reshaped by influencers and podcasters into stories of cosmic roulette. People couldn't look away, even when the news scared them. And that may be the most important part of September's legacy. It wasn't just a month of rocks in the sky. It was a moment when humanity was reminded of the bigger picture. We live on a small, fragile planet surrounded by countless objects hurtling through space, many of them indifferent to whether we're ready or not. For most of human history, the sky was a distant backdrop, something beautiful to admire. But in September 2025, it became a stage where danger, mystery, and wonder all played at once. We were spectators, powerless yet captivated, forced to face the reality that our place in the universe isn't as secure as we once thought. The story of September doesn't end there, of course, because as strange and frightening as those asteroids and comets were, they were only the opening act. Looming in the background was a visitor unlike any of them, a traveler from beyond the stars whose arrival transformed an already chaotic month into something historic. The asteroids may have passed us by, the comets may have broken and faded, but the interstellar object called Atlas promised to change everything. For all the chaos of that September, there was one moment that stood out, one single discovery that made even hardened astronomers stop and hold their breath. It was the night the world learned the name 2025 FA22, an ordinary designation for a decidedly extraordinary rock. FA22 wasn't supposed to be the star of anything. When it was first catalogued, it appeared as just another speck in the endless catalogue of near-Earth objects, one of countless chunks of stone drifting silently through the void. But the more scientists studied its trajectory, the more their calm eroded into something sharper. This rock wasn't just passing by, it was cutting it close, alarmingly close. At first, the numbers were buried in routine reports. FA22 would approach Earth within lunar distance, they said, close enough to keep an eye, but not enough to warrant alarm. That phrase, not enough to warrant alarm, was used often by agencies tasked with monitoring the skies, a way of reassuring the public that they were in control, that there was no need to panic. But the deeper those calculations went, the closer the estimates seemed to get. FA22 wasn't just approaching, it was threading a needle between the Earth and the Moon, passing through a region that isn't empty at all but crowded with satellites, space junk, and the infrastructure of our modern world. The idea that a piece of ancient rock forged in the earliest days of the solar system could streak past our most advanced technology felt almost poetic in its irony. The asteroid itself wasn't a giant in cosmic terms. It wasn't the dinosaur killer type, not the kind that could plunge Earth into a new ice age or wipe out entire species. Estimates placed it somewhere between 120 and 150 meters in diameter, roughly the size of a city block. That might not sound world-ending, but in impact scenarios, size is only part of the story. An object like FA22, slamming into Earth at tens of thousands of miles per hour, would unleash an energy release equivalent to dozens of nuclear bombs. Scientists estimated it could be 2,000 times more powerful than the explosion at Hiroshima. Picture that force not in a desert test site, but striking over a modern city. The blast wave would flatten buildings for miles. Fires would spread uncontrollably. Millions of lives could be altered in a single morning, and the global economy would stagger from the shock. The world would call it a tragedy of unprecedented scale, but in cosmic terms it would still be nothing more than a footnote, just another collision on a planet scarred by billions of years of impact. The unnerving reality is that FA22 wasn't discovered years in advance, the way disaster movies suggest. It wasn't tracked for decades while scientists plotted ways to divert it with rockets or nukes. Instead, like most near-Earth asteroids, it crept into our awareness only when it was already close. That's the part people rarely think about. Our detection systems are incredible, but they're also incomplete. The universe is vast, and the smaller the rock, the easier it is to miss, until it's bearing down on us. By the time FA22 had been properly observed and tracked, there was no time for anything other than waiting, calculating and hoping the numbers didn't change. The public didn't hear about FA22 until the week of its closest approach, when headlines began appearing with familiar phrases, city killer, close shave, Earth's near miss. It became one of those news stories that spread far beyond the science pages, igniting conversations at kitchen tables and offices. People who never thought about asteroids suddenly wanted to know how safe they really were. Could it hit us? What if the calculations were wrong? And perhaps most frightening of all, if this one almost slipped past, how many others were out there? The answers weren't comforting. Yes, FA22 missed. Yes, the odds had always been in our favor. But the deeper truth that Earth swims through a shooting gallery of rocks every single day was unavoidable. What made FA22 more than just another asteroid story was its timing. It arrived in the middle of the September surge, when the sky already seemed alive with threats. To many, it felt like the climax of a pattern. First smaller objects buzzing past, then comets brightening and breaking, and finally this, the closest call of them all. That sequence gave the impression of escalation, as if the universe was building towards something bigger. Rationally, scientists explained it as coincidence. Emotionally, it was hard to shake the sense that we were being warned. Even inside the scientific community, FA22 forced uncomfortable conversations. Planetary defense experts had long warned that humanity wasn't ready for a real asteroid threat. And here was proof laid bare. If FA22 had been just a few degrees different in its trajectory, there would have been no time to act. NASA's DART mission, which had successfully tested the ability to nudge an asteroid, was celebrated as a milestone. But it was only a proof of concept. It wasn't scaled, it wasn't fast enough, and it wasn't ready for the reality of a rock discovered on short notice. Space agencies around the world began using FA22 as a case study, a stark reminder that our best defense was still incomplete. Some argued it was luck that saved us. Others argued luck had nothing to do with it, that probability alone meant most rocks would miss. But for the average person hearing those arguments, the difference didn't matter. What mattered was the feeling that we had just dodged a bullet we hadn't even seen coming. The aftermath of FA-22's flyby was surreal. As it zipped past Earth, slipping by at a distance shorter than some communication satellites, millions of people followed live streams, watching as the invisible rock passed safely into the darkness beyond. There were no explosions, no fiery streaks in the sky, just silence. But that silence carried weight. For a brief moment, humanity had stared down the reality of its fragility, then sighed in collective relief as the danger drifted away. Social media lit up with jokes, memes and nervous humor. Guess we survived again. Earth undefeated. But beneath the jokes was a current of unease. Because if FA-22 was real, and if it came this close without warning, then so could the next one, and the next might not miss. And still, even as people processed that close call, the skies refused to calm down. New discoveries appeared in the days that followed. Other asteroids cruising by, other comets brightening. FA-22 hadn't been the end of the story. Only a chapter. In hindsight, it feels like the universe was setting the stage, preparing the world for something stranger. Because not long after FA-22 slipped into the void, the focus of September shifted again, this time to an object that didn't belong to our solar system at all. If the near miss with FA-22 rattled nerves, it was nothing compared to the eerie beauty of what happened next. Just as scientists were catching their breath from the asteroid surge, the attention of the astronomical world shifted to a ghostly traveler known as Comet Swan. On paper, Swan wasn't supposed to be anything remarkable. It was faint, fragile, one of countless icy remnants that occasionally drift into the inner solar system and put on modest displays before fading back into obscurity. But in September 2025, Swan refused to play its expected role. Instead, it transformed into a spectacle brightening, breaking, and behaving so strangely that even seasoned comet watchers were left scrambling for explanations. The first signs of Swan's strangeness appeared quietly. Observers noticed its brightness increasing faster than models had predicted. A comet brightening isn't unusual. It happens as sunlight warms the nucleus, vaporizing ice and releasing gas and dust that form its glowing coma and tail. But Swan's outburst was too sudden, too dramatic. Within days, a dim speck on sky charts turned into something visible to backyard telescopes, its coma swelling like a lantern in the dark. Amateur astronomers uploaded images of Swan glowing against starry backdrops, and the news began to filter through. This was no ordinary comet. The problem with fragile comets is that when they brighten too quickly, it often signals distress. These are ancient time capsules, dirty snowballs held together by dust and ice that has survived since the dawn of the solar system. But they are delicate. Too much heat, too much pressure, and they begin to fracture. Astronomers feared Swan was entering a dangerous stage of its life, one where its nucleus might split apart. And when comets split, the debris doesn't just vanish. Fragments scatter into new orbits, some of them crossing Earth's path. That's how meteor showers are born, but it's also how hazards can emerge. A single cometary fragment might burn up harmlessly in the atmosphere, creating a beautiful streak of light. A larger one could become something far deadlier. What made Swan so unnerving wasn't just its physical instability, but its timing. Remember, this was the same month when asteroids seemed to be swarming us. FA-22 had already shown how vulnerable Earth could be. Now, as if on cue, here came a comet unraveling itself across the sky. It felt orchestrated, like another act in a cosmic play. People began to connect the dots, drawing lines where science insisted there were none. On message boards, whispers spread that Swan's breakup was connected to the other strange sightings, that something in deep space was disturbing the balance and flinging objects toward us. Scientists pushed back with logic and probability, but it didn't matter. The feeling was already there, woven into the public imagination. As Swan brightened, its tail began to split, forming delicate fans of dust visible through larger telescopes. To some, the sight was mesmerizing, a celestial painting unfolding across millions of miles. To others, it was terrifying. Each branching filament of that tail represented instability, a nucleus cracking and releasing material in unpredictable bursts. Observers reported flare-ups, Sudden surges of light where jets of gas erupted from beneath the comet's crust. In moments like those, Swan seemed alive, almost willful, as if it were lashing out at the void. The fascination was undeniable. Night after night, people stayed up late, pointing binoculars at the faint glow of Swan as it inched across constellations. News outlets covered it not as a distant curiosity but as part of the ongoing September saga. First asteroids, now comets, one headline read, "What's happening in our skies?" Astronomers were bombarded with questions, many of them difficult to answer in simple terms. How likely was Swan to break apart completely? Could Earth be in danger if it did? Why was all of this happening now? The honest answers, maybe, unlikely but not impossible, and we don't really know, only fueled more speculation. For scientists, Swan became a case study in the fragility of small bodies. Comets are windows into the past, their ices preserving the chemistry of the early solar system. When one begins to disintegrate, it reveals secrets hidden for billions of years. Spectrometers detected unusual ratios of gases, hinting at complex chemistry locked inside. Some even suggested that comets like Swan might have carried the building blocks of life to Earth in its infancy. That idea, comets as bringers of life, but also potential bringers of destruction, added a mythic quality to Swan's story. It wasn't just a chunk of ice, it was a messenger, one that might outlive its message if it shattered entirely, yet the sense of unease never faded. The September surge had already primed the world to expect disaster, and Swan's behavior felt like another warning. In conversations online, people compared it to a candle burning too brightly before it flickered out. Some even saw symbolism in its name. A swan, after all, is often associated with final acts. A swan song, a last performance. Was Comet Swan making its final appearance, blazing brightly before tearing itself apart? And if so, what debris might it leave behind for Earth to encounter months or years down the line? As the comet drew closer to perihelion, the point nearest to the Sun, the tension only grew. Most comets become more unstable at this stage, and Swan was no exception. Astronomers debated whether its nucleus would survive the encounter. If it did, it might return in future centuries. If it didn't, it would dissolve into dust. A spectacular finale, but also a dangerous one. For the public, those debates blurred into a single question: what happens next? The answer was both reassuring and unsettling. Most likely, nothing dramatic would happen to Earth. That most likely was cold comfort in a month when so many unlikely things had already occurred. In the end, Swan held together barely. It dimmed and brightened, flared and fractured, but it didn't vanish completely. Still, the impression it left was lasting. It had been a reminder that comets are wild cards, unpredictable and fragile, capable of dazzling beauty and quiet menace at the same time. Its sudden brightening and chaotic behavior gave September an almost cinematic arc, turning the night sky into both a stage and a warning. When historians of science look back at 2025, Swan will likely be remembered as one of the symbols of that strange month. A comet that should have been unremarkable, but instead became part of a larger mystery. Was it coincidence that Swan unraveled at the same time asteroids swarmed past Earth? Or was it a thread in a bigger tapestry, one we're only beginning to see? That question lingered in the minds of many as September drew to a close, and just when it seemed the skies might calm again, another shadow appeared, one far older, far more infamous, and far more terrifying than Swan could ever be. While Comet Swan was unraveling and dazzling the night skies, another name quietly resurfaced, a name that had haunted scientists and the public alike for nearly 2 decades. Apophis. Unlike the fragile comet, Apophis was not an unknown, not a new discovery or a sudden surprise. It was an old fear returning, a reminder of a threat humanity had already stared down once before. To anyone who followed the news back in the early 2000s, Apophis was synonymous with danger, a celestial bullet that once seemed to have Earth squarely in its sights. Though calculations have since ruled out the possibility of a collision, its looming flyby in 2029 still hangs over us like a dark prophecy. And in the chaos of September 2025, with rocks and comets already invading the headlines, Apophis felt less like a future event and more like an inevitable shadow drawing closer. Apophis takes its name from the Egyptian god of chaos and destruction, a fitting title for a rock that once terrified the scientific community. Discovered in 2004, Apophis was initially calculated to have a small but frightening chance of impacting Earth, and for weeks the asteroid dominated headlines, sparking conversations not just among scientists, but across the globe. The mere idea of a known date for potential planetary catastrophe ignited imaginations. Could we stop it? What would happen if we couldn't? Would Apophis be the rock that ended humanity's story? The asteroid was quickly promoted to the top of NASA's Century Risk Table, a list of potential impact threats, and it became a symbol of both our vulnerability and our ingenuity as a species. Eventually, refined observations ruled out a collision in 2029, but the shadow remained. Even if Apophis would miss this time, the fact that it could come so close, closer than many satellites, was unsettling enough. For the public, Apophis was a ghost that never quite went away, resurfacing every few years in headlines, documentaries, and speculative fiction. In classrooms, it was used as an example of planetary defense. In podcasts and conspiracy forums, it was painted as a cover-up, with whispers that scientists were downplaying its real threat. By the time September 2025 arrived, Apophis was less an object in space and more a cultural archetype, a reminder that Earth's cosmic lottery ticket could be punched at any time. And when FA22 and Comet Swan turned September into a month of celestial anxiety, Apophis naturally returned to the spotlight. People began asking, if so much is happening now, what will happen when Apophis arrives? What makes Apophis different from the September surge is scale. Where FA22 was measured in city block dimensions, Apophis is colossal by comparison. At roughly 370 meters in diameter, it carries more mass, more momentum, and more destructive potential. An impact from Apophis would be beyond catastrophic. Cities wouldn't just be destroyed, they'd be erased, reduced to craters. Entire regions could suffer devastation, with shockwaves rippling across continents. While not large enough to end life on Earth, it could collapse economies, alter climates, and spark crises unlike anything humanity has faced in recorded history. That is why Apophis isn't just a rock in the sky, it's a symbol of the fragile balance we live under every single day. In September, Apophis's relevance wasn't in its immediate threat. 2029 was still years away, but in the way it reminded us that big rocks don't just pass by in textbooks, they pass by in real life. The month's barrage of smaller objects was unsettling enough, but Apophis loomed as a grim comparison. If something the size of FA22 had come close enough to rattle nerves, what would it mean for humanity to watch an object the size of Apophis sweep across the sky, closer than the moon, closer even than our satellites? That's not science fiction. That's 6 years away. In that sense, September's chaos became a rehearsal, a psychological primer for the event that will inevitably dominate global attention. Scientists were quick to remind people that Apophis will not hit us, that years of calculations have narrowed its trajectory with stunning accuracy. But reassurance has limits, especially when the object in question is named after a god of chaos. To many, the mere idea of such a close pass was terrifying. In forums, conversations mixed real science with conspiracy, blending probabilities with paranoia. What if the calculations are wrong? What if Apophis fragments or is perturbed by some unseen force? What if, like so many surprises in September, the impossible suddenly becomes possible? Rational minds dismissed these questions, but emotion isn't rational, and September had already proven that the universe doesn't always behave the way we expect. The return of Apophis to the public imagination also reignited discussions of planetary defense. The DART mission in 2022 had shown that humanity could nudge a small asteroid off course. That was a triumph, proof that Earth might not be powerless in the face of cosmic threats. But DART targeted a much smaller body, and it had years of preparation. Apophis is larger, faster, and on a trajectory that can't be easily altered. Scientists began to discuss scenarios not just in the halls of space agencies, but in open forums, asking what humanity would really do if something like Apophis were ever confirmed on a collision course. Could we launch a deflection mission in time? Would global governments cooperate? Or would politics and bureaucracy slow the response? These weren't idle questions. They were the kind of scenarios that September made impossible to ignore. Perhaps most unsettling was the way Apophis symbolized inevitability. It was out there, hurtling toward its rendezvous, unaffected by human wishes or fears. FA22 had been a surprise, Swan had been a spectacle, but Apophis was an appointment, a date written into the calendar of the cosmos. That knowledge, Knowing exactly when a vast rock will skim past us creates a unique kind of tension. It's like watching a slow-motion car crash, where the collision never comes but the anticipation never ends. September reminded us how fragile we felt in the face of uncertainty. Apophis reminded us that sometimes certainty isn't much better, and so in the chaos of September, Apophis's shadow grew. Even though it wasn't arriving for years, its presence was felt in every conversation, every news story, every whisper about the dangers of space. People couldn't help but imagine the sight of it in the night sky, a glowing streak brighter than most stars, arcing across the heavens as a silent reminder of how small we are. In that sense, Apophis became part of September's narrative, not as an active participant, but as the looming question mark at the end of every sentence. If this is what the skies look like now, what will they look like when Apophis comes? But September wasn't done yet. The asteroids had surged, Swan had flared, Apophis had cast its shadow, and then, out of the blackness came something stranger still. A rock that didn't belong to Earth's neighborhood at all, an interstellar visitor carrying secrets from beyond the solar system. Its name was Atlas, and its arrival turned a month of cosmic chaos into something historic. By the time September seemed ready to exhaust itself with asteroids and comets, another revelation appeared that made everything else feel small by comparison. Out of the silent depths of space, far beyond the realm of all planets, telescopes picked up a faint, fast-moving object with a trajectory unlike anything seen in years. At first it was just a dot against the stars, unremarkable to the casual observer, but as astronomers tracked it night after night, its strangeness became undeniable. Its orbit wasn't elliptical like the asteroids bound to our sun. It wasn't parabolic like the long-period comets that return after thousands or millions of years. Instead, it was hyperbolic, an unmistakable signature that told scientists this object did not belong here. It hadn't been born in our solar system at all. It had come from somewhere else. They named it 3I Atlas. The designation told its story, the third interstellar object ever recorded. Following in the footsteps of the enigmatic ʻOumuamua in 2017, I stood for interstellar, a badge so rare it had only been used twice before in all of human history. That alone would have been enough to spark fascination. But Atlas was different. Unlike its predecessors, it was discovered during a time when the sky was already chaotic, when asteroids and comets were arriving in clusters and the public was already primed for wonder and fear. To many, Atlas wasn't just another strange visitor. It was the climax of September's performance, the final act in a cosmic play whose meaning no one could quite decipher. From the beginning, Atlas distinguished itself with peculiar traits. Its brightness didn't behave the way astronomers expected. Instead of a steady glow, it seemed to pulse, brightening and dimming in ways that suggested complex activity. Some nights it displayed multiple tails, thin wisps stretching across millions of kilometers, as though the object itself couldn't decide how to behave. This wasn't the quiet glide of a simple rock. It was a spectacle, alive with energy, unpredictable and uncanny. For some, it brought back memories of ʻOumuamua, the cigar-shaped object that had baffled scientists with its unusual acceleration and lack of a visible tail. But where ʻOumuamua had seemed frustratingly silent, Atlas was noisy, its chemistry shouting signals no one quite understood. Spectral analysis deepened the mystery. When scientists studied the light reflected and absorbed by Atlas, they found a chemical composition unlike any comet or asteroid seen in our solar system. It was extraordinarily rich in carbon dioxide, with traces of nickel far stronger than expected and iron far weaker. That imbalance made little sense if Atlas had formed in an environment like ours. It suggested an alien birthplace, a solar system where the chemistry of planet formation played by different rules. Some speculated that Atlas was a fragment from a world that no longer existed, a shard hurled across interstellar distances after some cataclysm in another star system. Others wondered if it was simply a reminder that the galaxy is diverse, and that our own solar system is just one expression of countless possibilities. Whatever the answer, the message was clear. Atlas was not like us. It was something other. The discovery of its trajectory only deepened the intrigue. Atlas wasn't looping around the sun like the objects bound to our star's gravity. It was just passing through, a brief visitor on a journey that had taken millions, perhaps billions of years. Its speed was astonishing, fast enough to break free from the sun's pull, fast enough that once it passed, it would be gone forever, never to return. That impermanence gave its presence a haunting quality. We had only one chance to study it, One fleeting window before it slipped back into the endless night. Miss it, and the secrets it carried would vanish with it. For the public, Atlas became the most captivating symbol of the September surge. If FA-22 had been a threat and SWAN a warning, Atlas was a mystery, a messenger from beyond the familiar. Social media lit up with questions that scientists themselves could not easily answer. Where did it come from? What had it seen in its journey across the galaxy? Could there be others like it, unseen in the dark, crossing paths with Earth every year without us ever knowing? The reality is that scientists believe billions of such objects exist, drifting through the Milky Way like seeds scattered by invisible winds. Most are too faint to detect, too small, or too distant. Atlas was a rare exception, a lucky alignment of size, brightness, and timing that let us glimpse something larger than ourselves. And yet, the timing was what truly unsettled people. Why now? Why in the same month that dozens of asteroids had rushed past us, and comets had brightened and broken apart? Statistically, there was no reason to believe Atlas was connected to them. Its interstellar trajectory was completely independent, the product of ancient forces far beyond our solar system, but emotionally it felt like part of the same story, as though the universe had chosen September to remind us of its scale and unpredictability. Some speculated that Atlas wasn't a coincidence at all, but part of a cluster of interstellar fragments traveling together, their paths aligned long ago by some distant catastrophe. Others, leaning into conspiracy, suggested it was a probe, a fragment of alien technology camouflaged as a comet. Just as some had speculated with ʻOumuamua, mainstream scientists dismissed such ideas, pointing to Atlas's volatile chemistry and comet-like activity. But in the court of public opinion, mystery always outshines certainty. What made Atlas so compelling was that it invited everyone to ask questions bigger than themselves. In a world weighed down by politics, economics, and daily struggles, Atlas was a reminder of the cosmos, of the galaxy stretching far beyond Earth. It was proof that our solar system is not an isolated bubble, but a crossroads on an infinite highway. Something had traveled across the void to reach us, carrying with it information about places we may never visit. To look at Atlas was to glimpse the larger stage of the universe, to feel both small and connected at the same time. As scientists worked feverishly to gather data, the clock ticked. Every night mattered. Every observation was a chance to capture knowledge that could never be replicated. They pointed the most powerful telescopes on Earth toward it, hoping to squeeze every photon of information from its passing light. Plans were drafted to track it through December, when it would swing closest to the sun, perhaps revealing even more secrets as it heated and shed its layers. But already many knew the truth. We would never fully understand Atlas. Like ʻOumuamua before it, it would leave behind more questions than answers, a riddle written across the stars. In the larger story of September, Atlas was the turning point. FA-22 had scared us. SWAN had unsettled us. Apophis had reminded us of inevitability. But Atlas was different. It wasn't about fear or survival. It was about perspective. It was about realizing that the universe is larger, stranger, and more mysterious than we can ever fully comprehend. And as September drew to a close, that realization carried with it both awe and unease. If Atlas was just one of countless travelers, what else was out there, passing silently in the dark, waiting for its moment to cross our path? If the discovery of Three-Eye Atlas was already enough to capture the world's imagination, what came next pushed it into the realm of the uncanny. For most comets, their stories can be told in predictable patterns, a mix of frozen water, carbon-based molecules, and silicate dust, with trace amounts of metals that reveal themselves under the right light. Astronomers had studied hundreds of these icy wanderers, each with its quirks but all belonging to the same basic family. They were the leftovers of solar system formation, the crumbs of planetary construction swept to the outer edges, waiting to be nudged inward. Atlas, though, did not belong to that family. Its chemistry made that clear. It was a stranger, a misfit, and what it revealed left experts questioning not just where it came from, but whether our entire understanding of planetary formation was too narrow. Spectroscopic analysis, the science of breaking light into its component wavelengths, was the key to decoding Atlas's secrets. When astronomers pointed instruments at it, they expected to see the familiar fingerprints of volatile compounds, water vapor, carbon monoxide, maybe some methane or ammonia. Instead, they found something astonishing. Atlas's spectrum was dominated by carbon dioxide, far beyond what any known comet in our system displayed. It wasn't just present, it was overwhelming, a primary component of its outgas. To put it in perspective, imagine opening a fridge and expecting water ice only to find a block of dry ice instead. That was the kind of reversal scientists were facing. But it didn't stop there. When they compared the abundance of metals in Atlas's signature, they found another puzzle. In our solar system, comets typically show stronger traces of iron compared to nickel, a reflection of the way our star and planets condensed from the protoplanetary disk billions of years ago. Atlas, however, flipped that expectation. It carried far more nickel than iron, a balance that seemed almost alien. It was as if the star system where Atlas had formed played by an entirely different rulebook, where the recipes for planet building leaned toward combinations unfamiliar to us. For planetary scientists, this was exhilarating and deeply unsettling at once. It was proof that not all planetary nurseries are alike, that the diversity of worlds across the galaxy is wider than we had imagined. This strange cocktail of chemistry sparked debate immediately. Some argued that Atlas might have originated in a system around a carbon-rich star, a place where the building blocks of planets tip toward chemistry that feels exotic compared to ours. Others wondered if Atlas might not be a comet at all in the traditional sense, but a fragment of something larger, a shattered moon, a crust peeled away from a destroyed planet, hurled into interstellar space by catastrophic collisions long ago. If that were true, then Atlas was not just a traveler but a survivor, carrying within its strange mixture the echoes of an ancient disaster. What made it even more mysterious was the way it behaved. Unlike typical comets, whose outgassing follows relatively smooth curves as they approach the sun, Atlas showed erratic bursts. Its carbon dioxide jets seemed to erupt episodically, like the object itself was breathing in fits and starts. At times it flared brighter than expected, then dimmed suddenly, as though its chemistry was layered in unpredictable strata. Some scientists speculated that the strange nickel-iron balance could influence the way heat propagated through its surface, causing uneven sublimation. Others admitted they simply didn't know. The truth is that when it comes to interstellar visitors, our sample size is pitifully small, with only 3 on record: ʻOumuamua, Borisov, and now Atlas. Every new detail feels both extraordinary and impossible to fully contextualize. For the public, the chemistry story quickly spiraled into speculation. Dry technical phrases like carbon dioxide dominance became twisted into wild theories online. Some claimed Atlas was an artificial object, engineered by alien civilizations to mimic a comet, but betraying its nature through unusual composition. Others latched onto the nickel abundance, arguing it could suggest technological material, like alloys or industrial byproducts. While mainstream astronomers dismissed such ideas, they understood why people latched onto them. The chemistry wasn't just unusual, it was unprecedented, and whenever the universe delivers something unprecedented, mystery fills the gaps left by incomplete understanding. There was also a haunting philosophical undertone to Atlas's chemistry. If this object was formed billions of years ago in some distant star system, then the molecules it carried were older than Earth itself. Before our sun ignited, before our planets coalesced, Atlas was already drifting through the galaxy, preserving the chemical story of a place long gone. To study it was to hold a mirror to cosmic history, to realize that we are just one of countless possible outcomes written in the language of chemistry. If life could arise here, why not there? And if the chemistry of Atlas hinted at different planetary rules, might it also hint at different biological ones? These were questions too large to answer, but they hovered in the background, amplifying the sense of awe. And yet alongside the awe was unease. For all its strange chemistry, Atlas was still a physical body, hurtling at unimaginable speed through our cosmic neighborhood. Its flares and eruptions suggested instability. Some wondered whether it might fragment as it neared the sun, just as fragile comets often do. If that happened, pieces of Atlas could scatter unpredictably, potentially complicating our already chaotic September skies. Though the chances of any fragment threatening Earth were slim, the timing alone made the thought impossible to ignore. After weeks of asteroids and comets swarming near us, the idea that an interstellar visitor could add its own debris to the mix felt less like a thought experiment and more like a possibility. In laboratories and observatories, scientists pressed for every scrap of data. The nickel-to-iron anomaly became a focal point, with some researchers suggesting it could hold the key to understanding not just Atlas, but interstellar formation itself. Was there a region of the galaxy where metallic distributions were skewed? Could this tell us about the life cycles of distant stars, the supernovae that seeded their disks with elements. Atlas became not just an object but a cosmic sample jar, a chance to peek into chemical processes far beyond the reach of our spacecraft. And for storytellers, Atlas became a symbol. It wasn't threatening us like FA-22. It wasn't dazzling with instability like Swan. It wasn't looming in the future like Apophis. It was simply strange, irreducibly alien, proof that the universe is bigger than our expectations. Its chemistry was like a message written in a dialect we barely understand, a reminder that we are not the measure of all things. To look at Atlas was to confront the truth that Earth is one experiment among many, and that the galaxy has been conducting those experiments for billions of years. As the data rolled in, one conclusion became unavoidable. Atlas was not like anything we had seen before, and we might never see its kind again. Its chemistry was a fingerprint from another world, a signature of a system we would never visit, a clue without a context. For all the graphs and spectra, for all the excitement of discovery, the story ended not with answers but with a deepened mystery. Atlas was a riddle, and its chemical strangeness ensured that the riddle would endure long after it slipped back into the dark. And so, as September faded into October, the world was left with an uneasy feeling. The skies had been alive with danger and beauty, with threats and wonders, but Atlas stood apart. It wasn't a near miss, wasn't a warning shot. It was a whisper from somewhere else, carrying with it secrets that might never be deciphered. And as its unusual chemistry burned across our instruments, one question grew louder. What else is out there, traveling the void, waiting for its turn to remind us how little we truly know? The chemistry of 3I Atlas was enough to make scientists shake their heads in disbelief, but the way it behaved in the sky only deepened the mystery. For most comets and asteroids, once you've tracked them long enough, their movements and outgassing patterns become predictable. They follow physics like dancers following choreography, graceful arcs, steady brightenings, tails that fan out in familiar ways as solar radiation tears at them. But Atlas refused to follow the script. It was erratic, wild, a traveler that seemed determined to keep everyone guessing. In some ways it behaved like a comet. Yes, outgassing, shedding material, flashing with bright surges. In others, it defied explanation. It was as if Atlas had come to remind us that the cosmos is never as orderly as we pretend it to be. One of the first oddities was its light curve, the way its brightness rose and fell. Normally, as comets approach the sun, they brighten smoothly as sunlight sublimates their frozen material. But Atlas's curve looked like a heartbeat monitor, spiking and dipping in unpredictable bursts. Some nights it would flare suddenly, glowing far brighter than expected, as though a violent jet had burst from beneath its surface. Hours later, it would dim again, almost as if the energy had been spent in a single desperate gasp. Astronomers compared it to a sputtering flame in the wind, unsteady, alive, struggling against forces it couldn't control. Then there were its tails. Most comets grow one tail, a stream of dust and gas trailing behind them. Some form two, one dominated by dust and the other by ionized gases pushed by the solar wind. Atlas, however, seemed to sprout multiple thin tendrils branching and twisting in unexpected ways. Images captured by telescopes showed it shedding material in arcs that bent and curved unnaturally, like streamers whipping in different directions at once. This wasn't unheard of, but it was rare, and the way Atlas's tails shifted over days made it seem restless, unstable, as though something inside it refused to settle. And then there was the tumbling. Careful measurements of Atlas's light variations suggested it wasn't rotating smoothly like most small bodies. Instead, it was wobbling chaotically, tumbling end over end, with no clear rhythm. Scientists believe such behavior can happen when an object is unevenly heated, when jets erupt at odd angles and send it spinning. But with Atlas, the pattern seemed unusually erratic, as if it were caught in a tug-of-war with its own outgassing. Some even speculated that this tumbling might explain its episodic flare-ups, like a pinwheel sputtering as bursts of gas fired from unpredictable vents, sending the object lurching in new directions. This unpredictability drew inevitable comparisons to ʻOumuamua, the first interstellar visitor. That object had also tumbled strangely, accelerating in ways no one could fully explain. For years, debates raged over whether ʻOumuamua was a comet, an asteroid, or something entirely different. Some even whispered it might have been artificial, a derelict probe drifting between stars. With Atlas, the behavior was different, but the echoes were there. Another interstellar object, another unpredictable light curve, another challenge to the tidy boxes we put cosmic objects into. Once again, the universe seemed determined to tease us with riddles just beyond our grasp. For the public, Atlas's erratic behavior was irresistible fuel for speculation. Every flare became a headline. Every odd tale became a mystery. Images of its branching streams and sudden brightening spread online with captions asking whether this was a comet or something else entirely. Scientists stressed that the behavior was consistent with a volatile comet from another star system, but those reassurances did little to silence the chatter. After all, the same scientists had admitted Atlas's chemistry was bizarre, unlike anything we'd seen before. If its chemistry was alien, why not its behavior? And if both were alien, why not consider possibilities outside the ordinary? Even among professionals, there was a sense of unease. The truth is that science thrives on patterns. When something defies those patterns, the explanations often take years to emerge, and in the meantime the object becomes a kind of open wound in our understanding. Atlas was one of those wounds. It didn't obey our models. It didn't behave like the comets we thought we knew. Every time astronomers thought they had a handle on its behavior, it shifted again, slipping through the cracks of our knowledge. In a month already filled with surprises, this only heightened the sense that September was not normal, that something larger was unfolding. There was also a haunting quality to Atlas's instability. Unlike the asteroids, which brushed past us like bullets narrowly missing their target, Atlas seemed to embody fragility. It was a reminder that even in the cold of space, time wears everything down. This object had been traveling for millions, maybe billions of years, tumbling across interstellar gulfs, carrying its strange chemistry across unimaginable distances. And now, as it entered the warmth of our sun's domain, it began to shudder and fracture, like an ancient traveler exhausted by its journey. Every flare, every tail, every wobble was like a sign of age, a relic crumbling under the pressure of finally being seen. Speculation turned poetic. Some described Atlas as a cosmic messenger, its chaotic behavior a kind of desperate signal from another world. Others saw it as a dying ember, burning bright in its final moments before dissolving forever. A few even argued that its unpredictability wasn't just a quirk, but a sign that interstellar comets may follow rules we've never imagined, that the processes shaping them are more complex, more diverse than we've been prepared to understand. Each theory added to the aura of mystery, and each night it lingered in the sky. The questions only grew louder, and yet, for all its strangeness, Atlas also brought awe. The images of its tangled tails, of its sudden bursts, were beautiful in their unpredictability. To watch Atlas was to watch chaos in motion, a celestial performance that no one had choreographed. It was messy, irregular, alive. In a universe where so much seems cold and unchanging, Atlas was dynamic, a reminder that even the stars are not immune to surprise. People stayed up late to watch, not just because they feared it, but because they couldn't look away. For scientists, the focus turned to what this behavior meant for Atlas's future. Would it survive its passage around the sun, or would it fragment like so many fragile comets before it? If it broke apart, would we get one final surge of brilliance, or would it fade into nothing, another anonymous streak of dust lost in the void? The stakes weren't just scientific, they were emotional. Humanity had been given a chance to witness something that had traveled from beyond the stars, and no one wanted to see it vanish too soon. But comets do not care about human desires. They burn, they break, they vanish, leaving behind only questions and memories. Atlas would be no different. In the grand arc of September, Atlas's erratic behavior wasn't just another anomaly. It was a crescendo, a heightening of tension, before the inevitable fall. It had arrived not quietly, not predictably, but with a kind of chaotic defiance, and in that chaos, it reflected something back at us: the fragility of prediction, the limits of certainty, the truth that the universe is not here to comfort us with order. Atlas didn't need to follow our rules. It followed its own, written in a language older than Earth, older even than the sun. As telescopes continued to watch, one thing became clear: Atlas would not answer all the questions it raised. It would flare, it would tumble, it would confuse and astonish. Then it would leave, vanishing back into the interstellar dark. What it left behind was not certainty, but wonder, and perhaps unease. Because if Atlas could be this strange, this unpredictable, then what else is out there? What other visitors, tumbling silently through the void, might cross our path in the years to come? As the story of Three-Eye Atlas unfolded, its bizarre chemistry and erratic behavior were more than enough to keep scientists occupied. But outside the observatories, a different kind of narrative began to take hold. In the public imagination, Atlas wasn't just another comet or interstellar rock. To many, it was something far stranger, perhaps even something deliberately crafted. The rumors began quietly, seeded in online forums and speculative podcasts. But by the time Atlas's chaotic light curve and alien chemistry were making headlines, whispers of alien technology had already spread across social media. And as history had shown with ʻOumuamua, once that kind of speculation begins, it's almost impossible to contain. The comparison was inevitable. ʻOumuamua, the first known interstellar visitor discovered in 2017, had confounded astronomers with its strange shape and unexplained acceleration. It tumbled like a shard of glass, stretched longer than it was wide, and seemed to speed up as it left the solar system without the kind of visible outgassing a comet should have. For years, scientists debated its nature, asteroid, comet, or something in between, but the strangeness lingered. In 2018, Harvard astronomer Avi Loeb ignited controversy by suggesting it might be artificial, perhaps a fragment of alien technology, a light sail drifting through space. Most scientists dismissed the claim, but the idea stuck. For the public, ʻOumuamua became less a rock and more a mystery, a modern Roswell written in starlight. So, when Atlas arrived, showing its own set of anomalies, unprecedented chemistry, unpredictable brightenings, multiple tails, chaotic tumbling, the parallel was irresistible. Once again, here was a visitor from beyond our solar system, and once again, it refused to behave like anything we understood. Was it coincidence that the only interstellar objects we'd ever seen were also the strangest? Or was there something more at play, something we weren't ready to admit? Those were the questions circulating online, and they spread faster than the cautious explanations provided by official sources. The alien speculation came in flavors ranging from playful curiosity to outright paranoia. Some argued that Atlas's unusual nickel-to-iron ratio was evidence of manufacturing, pointing out that certain alloys used in human technology share similar imbalances. Others claimed its episodic flares weren't random at all, but signals bursts of energy deliberately timed, perhaps even carrying information. Amateur analysts pored over light curve data, searching for patterns, convinced that Atlas was blinking messages we simply hadn't learned to decode. A few even suggested that its chaotic tumbling wasn't instability, but control, a deliberate maneuvering system masked as randomness. Scientists pushed back against these claims, explaining that volatile ices could easily account for the flares, that nickel dominance was a plausible outcome in certain stellar nurseries, that chaotic tumbling was expected for a small body heated unevenly by the sun. But reason rarely wins against mystery. The very fact that Atlas was interstellar made it exotic enough for people to suspend disbelief. After all, if it came from another star system, wasn't it already proof that the universe is stranger than we imagine? And if it was stranger, who could say what was possible? The timing didn't help. September had already been saturated with cosmic drama. Asteroids buzzing Earth, comet swan breaking apart, Apophis looming in memory. By the time Atlas entered the stage, people were primed for something extraordinary. The narrative practically wrote itself. September wasn't just a month of random celestial events, it was a story building toward revelation. Atlas in that narrative wasn't just an object, it was the messenger, the one that came from the stars to deliver meaning. Whether that meaning was scientific, symbolic, or alien in origin was left for the audience to decide. Media outlets fanned the flames. While most reported the scientific details responsibly, headlines often leaned into mystery. Phrases like alien visitor, cosmic messenger, and stranger than expected peppered articles. Documentaries rushed into production, eager to tie Atlas to the mythology of ʻOumuamua, and on YouTube, entire channels thrived on speculation, crafting narratives that blurred fact and fiction into irresistible clickbait. Was Atlas a probe, a fragment of a long-dead civilization, a warning even? These ideas weren't mainstream, but they were captivating, and once an idea captivates, it spreads like wildfire. Interestingly, even within the scientific community, the debates weren't entirely closed. While most rejected outright the notion of Atlas being artificial, Many admitted privately that its combination of anomalies was frustrating. Some wondered if perhaps ʻOumuamua and Atlas represented a class of objects we hadn't yet recognized, a new category of interstellar debris with properties unlike anything native to our solar system. Others speculated that interstellar objects we've spotted so far might be biased toward the strange simply because they're the easiest to detect. If Atlas had been more ordinary, maybe we wouldn't have noticed it at all. In that sense, the very act of seeing it may have filtered the sample toward the unusual. But even those rational explanations carried with them an edge of mystery. If the only interstellar visitors we can detect are the strange ones, then our picture of the galaxy is guaranteed to be skewed toward the uncanny. For the public, the distinction hardly mattered. The alien narrative was simply more fun, more dramatic, more shareable. People imagined Atlas as an ancient probe, wandering for eons after its creators had vanished. Others envisioned it as a kind of galactic seed, carrying not just chemistry but the potential for life, drifting endlessly until it encountered a planet like ours. The myths practically wrote themselves, woven from the twin threads of fear and wonder. What gave these myths power was the undeniable truth that we don't know much about Atlas, and we may never know. It will leave, just as ʻOumuamua did, vanishing into the interstellar night. The data we gather will be incomplete, the answers partial. Mystery is the vacuum left behind, and human beings are wired to fill that vacuum with story. In one version, Atlas is a relic of alien technology. In another, it's a messenger carrying warnings from beyond. In yet another, it's just a comet. Strange, yes, but natural, proof of the vast diversity of the galaxy. All three narratives coexist, feeding different needs. The scientist's hunger for knowledge, the dreamer's thirst for wonder, and the skeptic's desire for order. What cannot be denied is the effect Atlas had on us. It turned a month of celestial noise into a chorus, each piece resonating with the others, until the story felt too connected to be random. FA22, Swan, Apophis, Atlas. Each was a chapter, but Atlas was the one that left the biggest question mark. If an object could come from another star, tumbling chaotically, glowing with alien chemistry, and then vanish forever, what else might pass by unseen? And if some of those visitors were truly artificial, remnants of civilizations long gone, would we even recognize them? Or would we, as we did with Atlas, simply watch in awe, speculate endlessly, and then let them slip away into silence? In the end, whether Atlas was alien technology or not is almost beside the point. What mattered was that it forced us to confront the unknown, to stretch our imaginations into places science could not yet reach. It reminded us that the universe is larger than our categories, that mystery is not an exception but a rule, and perhaps in a strange way the rumors themselves were part of the story, evidence that when faced with the unexplained, humanity's first instinct is to tell tales, to imagine possibilities, to turn data into myth. Atlas will leave us soon, disappearing beyond the reach of our telescopes. The scientists will publish their papers, the headlines will fade, and the forums will move on to new conspiracies. But the impression it leaves will linger, woven into the fabric of our cosmic awareness. Alien or not, technology or ice, messenger or fragment, Atlas came to remind us that the stars still hold secrets and that sometimes the most powerful revelation is not an answer, but a question. By the time the world had digested the near-miss of FA22, the unraveling of Comet Swan, the shadow of Apophis, and the interstellar riddle of Atlas, one question lingered that no one could shake. Was this all just coincidence? Or was there a pattern? For scientists, coincidences happen all the time. The universe is vast, chaotic, and filled with countless objects, most of them indifferent to human concerns. Statistically, it was entirely possible that September 2025 had simply been an unusually busy month, a convergence of random discoveries amplified by our improved technology. But for the public, and even for many astronomers, it didn't feel random. It felt choreographed, as though the cosmos had staged a performance, unveiling one act after another, until the entire month became a crescendo of mystery and danger. The human mind is wired to search for patterns. It's what helped us survive in the wild, noticing connections between rustling grass and the approach of predators, or between storm clouds and the arrival of rain. And the cosmic scale, that same instinct compels us to connect dots across millions of miles. FA22's brush with Earth, Swan's unexpected brightening, Apophis's looming flyby, and Atlas's alien chemistry weren't just isolated events. They became puzzle pieces in a narrative, a constellation of meaning drawn across the skies. And the more people looked, the more connections they believed they saw. One theory that gained traction was gravitational clustering. The idea was simple. Maybe something in the outer solar system had disturbed the usual balance, sending a wave of objects inward. For years, astronomers have speculated about Planet 9, a hypothetical giant lurking beyond Neptune that could explain unusual patterns in the orbits of distant bodies. If such a planet exists, its gravitational influence might be enough to shuffle comets and asteroids into new trajectories, nudging them toward the inner solar system. Could September have been the moment when that influence finally revealed itself? Mainstream science remained skeptical. But for those already convinced of Planet 9's existence, the clustering of September felt like validation. Another theory focused on observational bias. Our telescopes and detection networks are better than ever, sweeping the skies with unprecedented precision. Perhaps September only felt crowded because we were finally seeing what had always been there. Improved surveys like Pan-STARRS and Atlas, the very network that spotted Three-Eye Atlas, were constantly expanding their reach. Maybe the rocks weren't new, just newly noticed. It was a comforting thought, one that suggested the universe wasn't suddenly more dangerous, just more visible. But comfort doesn't always win hearts, and many remained unconvinced. If the skies had always been this busy, why did it suddenly feel like a flood? For others, the answer wasn't gravitational or technological, but galactic. They pointed out that interstellar space is not empty, but filled with drifting debris from countless star systems. Earth's solar system moves through the Milky Way on a 225 million-year orbit, weaving through spiral arms dense with stars and dust. What if we had entered a region of higher density, a galactic tide pool where fragments of distant worlds were more common? It sounded like science fiction, but the possibility lingered. After all, Atlas was proof that interstellar objects exist and can cross our path. If one could arrive, why not many? And if many, why now? Then there were the more conspiratorial voices. To them, the clustering wasn't natural at all. Some suggested it was orchestrated by governments hiding the true scale of near-Earth threats, by extraterrestrial intelligences, sending signals in the form of celestial objects, or even by the universe itself, behaving as if it had intent. These ideas had little basis in evidence, but they thrived on the sense of unease. September felt uncanny, and when the uncanny arrives, logic often loses ground to imagination. For scientists, the debate was more nuanced. Some argued that randomness often produces clusters, just as rolling dice eventually produces streaks. A gambler may see a pattern, but mathematics explains it as chance. Others pointed to resonance effects, gravitational alignments that can temporarily funnel objects inward, creating bursts of activity that look like patterns even if they're short-lived. But what unsettled even the most rational minds was the sheer variety of September's events. Asteroids, comets, and interstellar visitors are different categories, shaped by different forces. To see all three flare into significance in such a short span felt improbable, no matter what the statistics said. Public fascination with the pattern question wasn't just about science, it was about meaning. Humans don't like randomness, especially when randomness threatens our survival. We prefer narratives, stories that connect events into something larger. For some, the September surge became a reminder of our fragility, a wake-up call that we are not insulated from the cosmos. For others, it became a sign of destiny, a belief that something momentous was unfolding in the heavens. And for many, it was simply a mystery, a puzzle that resisted explanation but demanded attention. The clustering also raised uncomfortable questions about preparedness. If this was just a random spike, fine, things would eventually quiet down. But if it was part of a broader pattern, if the solar system was indeed entering a denser field of debris, or if gravitational forces were aligning to send more objects our way, then September might not be the end of the story. It might be the beginning of a new era of heightened risk. That thought, once planted, was hard to shake. People began to imagine not just one September, but many months or years, when the skies would bombard us with rocks and ice, forcing us to face threats we had long ignored. Perhaps the most unsettling aspect of the pattern question was that it had no clear answer. Each explanation, gravitational nudges, observational bias, galactic tides, sheer coincidence, was plausible, but none could be proven, and so the question lingered, unresolved, hanging in the air like the objects themselves. Was September a fluke, or was it a glimpse into a deeper order of chaos, one we had only just begun to see? For storytellers, the lack of resolution was a gift. Mystery sustains attention far better than certainty. For scientists, it was a frustration, a reminder that knowledge is always partial, always provisional, and for the public it was both, a source of wonder and of dread. In the end, perhaps the most honest answer came not from the data, but from the experience itself. September had felt patterned, and that feeling mattered as much as the numbers. Whether or not the universe had truly choreographed the month's events, humanity would remember it as if it had. And as the month gave way to October, one thing became clear: the skies had given us not just a series of objects, but a story. A narrative woven from asteroids and comets, shadows and visitors, mysteries and near misses, and at the heart of that story was the question of patterns, whether the universe had meaning in its timing, or whether meaning was simply what we projected onto the void. But even as people argued over chance versus design, the cosmos refused to pause. More objects were being tracked, more surprises lay ahead. September had raised the question. The months to come would decide whether the answer would ever be given. If there was one thread that tied the entire September spectacle together, it was the uneasy realization that Earth is not nearly as safe as we like to imagine. We live beneath a thin atmosphere, walking on the fragile crust of a planet orbiting in a cosmic shooting gallery, and for much of history we've pretended otherwise. FA-22's close flyby, Comet Swan's dramatic breakup, shadow of Apophis's future return, and Atlas's alien strangeness were more than curiosities. They were warnings. Together they served as a wake-up call for planetary defense, a reminder that no matter how advanced our technology becomes, we are still vulnerable to forces from the sky. For centuries, humans looked at comets and asteroids as omens, signs of disaster sent by the heavens. In September, that ancient fear came roaring back, but this time it was paired with something new, the knowledge that the danger is real, measurable, and in some cases inevitable. FA-22 had been the most visceral reminder. Just 2 days before it swept past, we hadn't even known it existed. By the time our instruments caught it, there was no time to react, no time to prepare. Had its path been just slightly different, it would have slammed into Earth with the force of a nuclear weapon, leveling entire cities, and it would have done so without warning. That fact alone shook people to their core. It wasn't the largest asteroid, nor the most dangerous, but it was proof that small, fast objects can sneak past our defenses, arriving at our doorstep before we even know they exist. If FA-22 was a warning shot, it was one we were lucky to survive. Apophis brought a different kind of unease. Unlike FA-22, we've known about it for decades. We've tracked its orbit, mapped its trajectory, and calculated the dates of its future approaches. In 2029, it will pass closer than our geostationary satellites, bright enough to be seen with the naked eye as it streaks across the sky. For now, scientists say it poses no direct threat, but the very fact that an object 370 meters across, a rock big enough to cause continent-scale devastation, can pass within spitting distance of Earth is enough to unsettle anyone paying attention. Apophis represents inevitability, the uncomfortable truth that large asteroids will keep coming, and eventually one may be on a collision course. September reminded us of that inevitability, bringing Apophis back into public consciousness just as smaller objects were buzzing past. And then there was Atlas. While it posed no threat to Earth, its mere existence was a challenge. An interstellar visitor with alien chemistry and erratic behavior showed us that the unknown is not hypothetical. It is here, it is real, and it will keep arriving. If we cannot even fully explain a passing comet, how can we claim to be prepared for what the universe may throw our way? In a sense, Atlas was the most unsettling of them all, not because it threatened us directly, but because it reminded us of how little control we truly have. Knowledge is a kind of shield, and Atlas slipped right through it, reminding us that ignorance is its own kind of danger. The convergence of these events forced a conversation that many had tried to avoid. Planetary defense, the idea of detecting, tracking, and if necessary, deflecting dangerous objects, moved from the realm of science fiction to urgent necessity. For years, space agencies like NASA and ESA had worked quietly on monitoring systems, scanning the skies with telescopes, running simulations, even testing small-scale deflection missions. But September made the issue impossible to ignore. Ordinary people, scrolling through headlines, began asking the same questions experts had been wrestling with for decades. How much warning would we have if an object like FA-22 were bigger? Could we stop it? What if multiple threats arrived at once? The answers were sobering. The truth is that planetary defense is still in its infancy. We have only catalogued a fraction of near-Earth objects larger than 140 meters, a size considered large enough to cause catastrophic regional damage. Millions of smaller objects remain unseen, each one capable of devastating a city if it struck in the wrong place. Our early warning systems are improving, but September showed us how much can still slip through. When it comes to active defense, actually pushing an asteroid off course, we've only just begun. The DART mission in 2022 proved that a spacecraft can successfully nudge an asteroid, altering its orbit. It was a triumph, the first demonstration of planetary defense in action. But that was one test, against one small asteroid under controlled conditions. Against something larger or something we discovered too late, our options would shrink drastically. The events of September also exposed a deeper truth. Planetary defense is not just a scientific challenge, it's a political one. Building and maintaining the infrastructure to monitor and deflect threats requires funding, cooperation, and long-term planning, qualities that don't come easily in a world divided by borders and priorities. FA-22's close call sparked debates about international responsibility. Should wealthy nations bear the cost of planetary defense for everyone? Should spacefaring powers coordinate deflection strategies? Or would each nation act in its own interest? What if one country wanted to redirect an asteroid in a way that put others at risk? These questions are thorny, and September forced them back into the spotlight. For many people, though, the conversation wasn't about politics or strategy. It was about perspective. September peeled back the illusion of control, reminding us that our lives unfold under forces far larger than ourselves. The Earth feels permanent, immovable, eternal, but in reality, it is a vulnerable world, orbiting through a universe that does not bend to human will. Asteroids do not negotiate, comets do not pause, interstellar visitors do not wait for us to catch up. They arrive, they pass, they strike, they vanish. We can choose to prepare, or we can choose to hope for luck. September made it clear that hope alone is not enough. And yet, in the face of vulnerability, there was also a spark of something else: determination. Scientists spoke with renewed urgency about expanding sky surveys, building larger telescopes, and developing faster response systems. Engineers talked about scaling up deflection technologies, imagining missions that could push larger asteroids or even fragment them safely. Advocates began pressing governments to treat planetary defense not as a fringe concern, but as a central responsibility of civilization. If we can protect ourselves from threats we create, wars, pollution, climate change, then surely we should also protect ourselves from the ones we cannot control. September gave those advocates their strongest argument yet. The threats are not theoretical, they are real, and they are closer than we think. The irony is that September, for all its chaos, may one day be remembered as the month that changed everything. Not because disaster struck, but because disaster almost struck, and because wonder forced us to pay attention. It was the month that turned abstract risks into lived experience. The month that made planetary defense not a luxury, but a necessity. Whether humanity listens is another question entirely. Our history is filled with warnings ignored, with crises recognized only after the fact. But September is written in the sky, and the sky does not fade. We saw what could have happened. We saw what might still come. The choice of how to respond is ours. Perhaps the greatest lesson is this: the universe is not out to get us, but it is indifferent to whether we survive. Planetary defense is not about fighting an enemy. It is about acknowledging our fragility and taking responsibility for our survival. If we do nothing, another September will come, and it may not end as kindly as this one did. But if we act, if we choose to prepare, then maybe one day we'll look back on this strange month, not as the time we were nearly humbled by the sky, but as the turning point when we finally learned to stand against it. The skies of September had been filled with fire, with whispers of catastrophe, with visitors from beyond, but what lingered most was not the fear of impact or the thrill of discovery. It was the quiet recognition of how small and fragile we really are. Every asteroid that brushed past us, every comet that crumbled, every interstellar fragment that flashed and vanished, was a reminder that Earth is not the center of the universe, but a brief and delicate home, orbiting a star that itself is nothing more than a speck in a galaxy of hundreds of billions. For all our cities, our wars, our triumphs, and our histories, we are still at the mercy of stones and ice drifting through the void. That awareness, once stirred, is impossible to set aside. September became more than a story of near misses. It became a mirror held up to humanity, showing us not our power but our fragility. To stand beneath the night sky is to feel it. You look up, and you see not just points of light, but depth, distances so vast they cannot be imagined in human terms. You realize that the Earth is suspended in that immensity, shielded by nothing but luck, trajectory and timing. A rock like Fa-22 comes out of nowhere, and suddenly all the illusions of permanence shatter. A city, a civilization, even an entire species could vanish in an instant, erased not by our own mistakes, but by the indifference of the cosmos. It is humbling, terrifying, and oddly beautiful all at once. That is the paradox of fragility. The same awareness that reminds us how vulnerable we are also connects us to something larger, to a universe that existed long before us, and will exist long after we are gone. Atlas carried that message most strongly. It was not just a rock, not just ice, sublimating in the sun's heat. It was a traveller, older than Earth, older than the mountains or the seas, carrying with it the chemistry of a world we will never see. To witness it was to witness history beyond our history, to touch in some small way the great currents of the galaxy. Atlas reminded us that we are not unique. The same processes that shaped our solar system have been shaping others for billions of years, scattering fragments across the stars. Some of those fragments will wander forever, unseen and unknown. But every so often one crosses our path, and in that moment we are given a glimpse of the vastness that surrounds us. To ignore that glimpse would be to blind ourselves. To embrace it is to see clearly how thin the thread of our existence really is. And yet, fragility is not weakness. It is perspective. When you realize how easily life could end, how casually the cosmos can sweep aside entire worlds, you also begin to see the extraordinary unlikelihood of our survival. Against impossible odds, life arose here. Against further odds, it persisted, flourished, and built civilizations capable of looking back at the sky with curiosity instead of terror. That is the other half of the mirror September held up. Not just that we are vulnerable, but that we are here at all. The asteroids remind us of destruction, yes, but also of creation. Earth itself was born in chaos, shaped by collisions and impacts, sculpted by forces that nearly destroyed it. The same universe that threatens us also made us. In fragility there is also resilience, and in that resilience lies meaning. This perspective is not easy to carry. It demands that we look beyond the boundaries of our daily lives, beyond the arguments and ambitions that consume us. To see ourselves as fragile is to admit that we are temporary, that everything we build can be erased in a single strike. But it is also to recognize the urgency of now. If the future is uncertain, then the present matters more. If we are small, then our ability to look up, to wonder, to prepare, becomes all the more miraculous. Fragility does not diminish us. It defines us. It gives weight to our choices, to our science, to our dreams. September's events became a kind of cosmic parable. Fa-22 whispered of sudden endings, of how easily we could be caught off guard. Swan spoke of instability, of how even the brightest can shatter without warning. Apophis stood as inevitability, a reminder that some threats cannot be wished away, only faced. And Atlas was the messenger, the outsider, carrying with it the silent truth that the universe is larger and stranger than we dare imagine. Together they told a story not just of danger but of perspective. We are not the rulers of the cosmos. We are its children, clinging to a world that drifts through the same currents that fling stones and fire across the void. What people felt in September was not just fear. It was awe, that rarest of emotions, the one that cuts through arrogance and denial and forces us to see ourselves as part of something greater. Awe humbles, but it also inspires. To look at the sky and realize we are small is not to despair, but to understand that smallness is still something. We exist, we think, we wonder. That is no small thing in a universe of lifeless rocks and burning suns. Fragility is not the end of the story, it is the beginning. It is the reason we must protect what we have, cherish the fleeting moment of existence given to us, and expand our reach so that we are not bound to one fragile world forever. The cosmic perspective does not erase fear, but it transforms it. When we acknowledge our fragility, we stop pretending we are invincible. We stop wasting time on illusions of permanence and begin to prepare. September was not just a warning. It was an invitation. It was the universe reminding us that we can either face the truth of our place or ignore it at our peril. And in that choice lies the measure of humanity. Will we shrink from the vastness, or will we step into it with open eyes? Will we see our fragility as weakness, or as the reason we must endure? Perhaps the strangest gift of September was this. It made the universe feel close. Not distant, not abstract, but present. The asteroids were not ancient history. They were here now, brushing past Earth in real time. The comets were not metaphors. They were ice and dust unraveling before our eyes. The interstellar visitor was not a thought experiment. It was real, captured in data, glowing faintly in the night. For once, the cosmos was not just something we read about in textbooks. It was alive, immediate, demanding to be acknowledged. And in that immediacy, we saw ourselves for what they are, fragile, yes, but also awake, capable of wonder, capable of change. In the end, fragility is not a curse, but a perspective. And perspective is power. The same month that showed us how easily we could be struck down also showed us how much we have to fight for. To be fragile is to be aware. To be aware is to be alive. And to be alive in a universe as vast and indifferent as this one is nothing short of miraculous. September stripped away the illusions and left us with the truth. The question now is whether we will listen. When September finally gave way to October, the sky seemed quieter, calmer, as though the curtain had fallen on a drama too large for the stage of a single month. The asteroids moved on, the comets dimmed, and Atlas drifted further into the depths, destined to vanish into the darkness from which it came. But the silence was deceptive, for what lingered was not relief, but question. The aftermath of September was not closure, but a restless hum of curiosity and unease, as if the universe had delivered a message we were not yet able to translate. Scientists sifted through data, analyzing light curves, spectra, orbital calculations, and compositional model. Papers were drafted, conferences convened, theories proposed, yet for every answer there seemed to be two new uncertainties. The events of September did not settle the mysteries of the cosmos. They sharpened them, gave them edges that cut into our sense of security. Take FA-22, for example. It was gone as quickly as it came, slipping past Earth with nothing more than a whisper of danger. But its very near miss left scars of a different kind, scars in our confidence, in the systems we had trusted to protect us. If a rock of that size could arrive unseen until 2 days before its closest approach, what else was out there waiting to surprise us? The question became more than academic. Cities and governments wanted reassurance, but reassurance was thin. Telescopes can only see so much, and the void is vast. The aftermath of FA-22 was not panic, but it was a lingering discomfort, the kind that gnaws at the edges of thought when the night grows too quiet. Comet Swan left behind its own trail of ambiguity. Its sudden brightening and collapse had seemed like an omen, but in the cold logic of science, it was a process, a fragile body torn apart by its own journey. Yet even as astronomers explained the mechanics of its disintegration, something about Swan's timing lingered. Why then? Why in the same month as everything else? Coincidence is the easiest answer, but it is never the most satisfying. In the aftermath, Swan became more than a comet. It became a symbol of instability, of how quickly brilliance can unravel, of how even beauty in the sky is subject to collapse. People remembered it not as a scientific event, but as a story, a metaphor for the fragility not just of comets, but of life itself. Apophis, though still years away, left the deepest shadow. Its name resurfaced in headlines, its future flyby cast once more into the collective imagination. In the wake of September's other events, Apophis no longer felt like a distant curiosity. It felt sentient, looming, a reminder of inevitability. In living rooms and classrooms, people began to ask questions not about whether Apophis would strike, but about what would happen if something like it ever did. The aftermath of September made the abstract real. It turned numbers on a chart into visceral possibility. Apophis was not coming in September, but September had made sure we would not forget it was coming someday. And then there was Atlas, the visitor from beyond. Its departure left behind not clarity, but a vacuum. Spectra and data showed its alien chemistry. Observations confirmed its unpredictable flaring and chaotic tumbling, but none of it answered the deeper questions. Where did it come from? What forces shaped it? Was it truly just a fragment of ice and dust, or something stranger still? In the aftermath of Atlas's passing, speculation lingered like smoke after a fire. Scientists spoke cautiously about interstellar formation models, but the public spoke freely of alien probes, galactic messengers, and hidden meanings. The truth is that Atlas left us with no certainty, only wonder, and wonder is both gift and burden. It inspires, but it also unsettles. It leaves us looking up at the sky not with answers, but with questions that may never be resolved. Perhaps the most haunting aftermath of all was the pattern itself. The clustering of so many events in such a short time could be explained statistically, gravitationally, observationally, and yet it did not feel explained. The feeling that September had been special, orchestrated even, refused to fade. People talked about it in forums and podcasts, wrote articles and essays, whispered theories that ranged from the scientific to the conspiratorial. Was it a cosmic coincidence, or was it the beginning of a larger cycle? Was the solar system moving into a denser stream of debris? Was an unseen force at play in the outer reaches? Or was it simply our minds, desperate to weave order from chaos? The aftermath of September left that question unanswered, and perhaps unanswerable. For humanity as a whole, the lingering effect was perspective. The month had been a reminder that the universe does not revolve around us, that our planet is not shielded by destiny or design. We are exposed, suspended in a cosmic current that cares nothing for our survival. And yet, at the same time, September reminded us of our capacity to notice, to measure, to wonder. We may be fragile, but we are not blind. We may not control the skies, but we can study them, prepare for them, learn from them. In that duality, fragility and awareness, lies our greatest strength. The aftermath of September was not despair but recognition. Recognition that our place in the universe is small, but not meaningless. In homes and classrooms, children asked questions about asteroids, comets, and interstellar travelers. Teachers used September as a lesson, not just in science but in humility. Philosophers wrote about chance and destiny, about the search for patterns in a universe that may have none. Artists painted the sky in streaks of fire and light, capturing in color what words could not. September had left its mark not just on data charts and scientific journals, but on culture, on imagination, on the human need to find meaning in the stars. That was its aftermath, not closure, but inspiration laced with unease. Even as October unfolded, astronomers continued their watch. New objects were catalogued, new comets tracked, new asteroids mapped. The work did not stop, because the drama of September had ended. If anything, it intensified, driven by the memory of how fragile and unprepared we felt. The lingering questions became fuel for vigilance, for more telescopes, more surveys, more international cooperation. The aftermath was not just emotional, it was practical. Humanity had been reminded of its vulnerability, and for once it seemed willing to listen. But beneath the data and the policies, the deeper questions remained. Why did it all happen then? Was there meaning in the timing, or was meaning only what we gave it? What else is out there, beyond the range of our telescopes, waiting to pass by, waiting perhaps to collide? And the biggest question of all, what does it mean to live on a fragile world in a universe that does not pause for us? These are not questions science can fully answer. They are questions of philosophy, of existence, of perspective, and they are the questions September left behind, lingering in the silence after the spectacle had passed. The skies grew darker, quieter, but humanity had been changed. September would not be forgotten. It would live in memory as a month of omens, of warnings, of awe, of fragility. Its aftermath was not an ending, but a beginning, a reminder that we must keep watching, keep preparing, keep wondering, for the universe is vast. And September was only one chapter in a story still being written. September ended, but its shadow stretched far beyond its 30 days. The skies that had burned with near misses, collapsing comets, looming asteroids, and interstellar riddles grew quiet again. Yet the silence felt charged, as though the universe had spoken and then fallen still, waiting for us to decide whether we had heard the message. In many ways, the conclusion of September was no conclusion at all. It was a threshold, a door cracked open to a larger truth about the fragile planet we inhabit and the boundless cosmos that surrounds it. To walk through that door required more than telescopes and equations. It required humility, imagination, and the courage to see ourselves as we truly are, fleeting, delicate, and yet capable of wonder. The events of that month did not end in catastrophe. No city was struck, no world-ending rock came crashing down. Instead, what we faced was subtler but perhaps more profound, the recognition of our precariousness. FA22 reminded us that the sky is full of unseen dangers, small bodies that can slip past unnoticed until it is too late. Comet Swan showed us that even the brightest and most beautiful can unravel suddenly, leaving nothing but fragments and fading light. Apophis loomed in memory as a reminder of inevitability, of threats not yet here but certain to come. And Atlas, the alien wanderer, was the punctuation mark, the final act of September's play, showing us that the universe is far larger, far stranger than the confines of our solar system. Each of these events was remarkable on its own. Together they were overwhelming, almost too much for a single month to contain. But the true story was not the rocks or the ice or the alien fragments. The true story was us, how we responded, how we thought, how we felt. For in September the cosmos pulled back the curtain, and for once we looked, not just with curiosity but with awe, with dread, with wonder. We saw our fragility written across the sky, but we also saw our resilience in the act of noticing. That paradox, that we are vulnerable yet aware, was the gift and the burden September left behind. The conclusion of this story, if it can be called that, is not about answers but about questions. What is our place in the universe? A place so small that a rock no larger than a football field could erase an entire city. How do we live knowing that the threats above us are not personal, not directed, but indifferent, random, inevitable? Do we hide from that truth, or do we rise to meet it? These are not questions September invented, but it forced us to confront them in ways we had avoided for too long. The lesson of fragility is not despair, it is responsibility. If the universe is indifferent, then meaning must come from us. If the skies are unpredictable, then preparation must come from us. September was a wake-up call, a reminder that planetary defense is not science fiction but survival, that awe is not luxury but necessity, that humility in the face of the cosmos is not weakness but strength. In the end, we are small, yes. But smallness is not nothing. Smallness when aware can still matter. Smallness when determined can still endure. And yet, even as we speak of preparation and resilience, the questions linger, haunting like echoes in a canyon. Why September? Was it coincidence? Or was it simply the randomness of the universe condensed into one uncanny month? Or was it a glimpse of a larger cycle, a rhythm we cannot yet perceive? Science offers probabilities, but the human mind craves narrative, and narrative insists that meaning lies behind the clustering. Perhaps the meaning is nothing more than chance, or perhaps it is more, something written in the deeper laws of the galaxy, something we are only beginning to sense. That uncertainty is the conclusion's sharpest edge. The story does not resolve, it stretches forward into the unknown. But perhaps that is the point. The cosmos rarely gives us closure. It gives us glimpses, fragments, visitors like Atlas who arrive without explanation and leave before we can fully understand. It gives us comets that flare and die, asteroids that whisper past in silence, looming shadows that will one day demand reckoning. We want answers, but the universe gives us questions. And in those questions lies the true wonder. The conclusion is not an ending, but an invitation to keep watching, to keep searching, to keep asking. What September left behind, more than fear, was perspective. We saw ourselves as fragile, but fragility can be a source of unity if we let it. A rock falling from the sky does not ask what country it will strike, what borders it will cross. Its path is blind, its impact indiscriminate. In that truth lies an opportunity to see ourselves not as divided nations, but as a single species sharing one vulnerable world. September did not destroy us, but it reminded us that survival is shared, that our fate is bound together, whether we admit it or not. That perspective may be the most valuable gift of all. As the memory of September fades into history, its story will be retold in different ways. Scientists will remember it as a month of data, of anomalies and discoveries. Writers will remember it as a story of omens and symbols. Dreamers will remember it as proof that the universe is alive with mystery. And for ordinary people, it will linger as a strange time when the skies seemed closer than ever, when the cosmos reached down and brushed against our lives. Each retelling will shape the legacy of September, and perhaps that is fitting. For in the end, the meaning of the cosmos is not given to us. We create it, together, through the stories we tell. So what is the conclusion of September? It is not fear, though fear was present. It is not certainty, though data was gathered. It is not closure, though the month came to an end. The conclusion is a thought, simple and unsettling, that we are fragile, yes, but also aware that we live not apart from the universe, but within it, shaped by its dangers, awed by its mysteries, humbled by its scale, and that to live within it is not to seek safety, for safety is an illusion, but to seek meaning, to seek endurance, to seek wonder. The skies are quiet again, for now, but we know they will not remain so. The next FA-22, the next Swan, the next Atlas is already on its way, unseen, unmeasured, inevitable. September was a reminder not that we are doomed, but that we are alive in a universe that will always test us, always surprise us, always demand that we rise beyond our illusions of permanence. That is the true conclusion, not an ending, but a beginning. September is over, but the story continues, written not just in the stars but in how we choose to respond to them. And as the final trace of Atlas faded into the night, slipping back into the interstellar dark, a single thought remained, quiet but immovable, that the universe does not revolve around us, that it does not pause for us, that it does not explain itself for us, and yet somehow it still includes us. Against impossible odds, it gave us this fragile world, this brief moment, this chance to look up and wonder. September was the reminder. The conclusion is the choice. What we do with it is all that matters now. Even after September had ended, after the asteroids had moved on, after the comets had crumbled, and after Atlas had vanished into the darkness, something lingered in the human spirit that would not be quieted. The skies might have returned to their ordinary rhythms, but the minds that had watched them could not return so easily to complacency. Section 14, if there can be such a thing, is not a continuation of the events themselves, but of their consequences, how they reshaped our sense of myth, science, destiny, and survival. The story was not over when the month closed. In many ways, it was only beginning. For humanity, stories of the sky have always been more than observation. They have been identity, myth, prophecy. Ancient peoples looked at comets and saw omens of war, kings falling, empires collapsing. They looked at eclipses and saw gods warring, at meteor showers and saw the heavens speaking. September 2025, for all its telescopes and data, carried the same energy. People may not have spoken of gods, but they spoke of warnings, of patterns, of messages. The science explained the mechanics, yes, but the human mind reached instinctively for meaning. And in that reaching, September joined a lineage of sky stories stretching back thousands of years. We may live in an age of satellites and observatories, but when the heavens stir so violently, we still whisper like our ancestors did. What does it mean? This impulse to mythologize is not weakness, it is survival. Stories keep memory alive, numbers fade, but narratives endure. The aftermath of September has already begun to take on the shape of myth. In popular culture, novels, documentaries, and films frame it as the month the skies woke up, the time when humanity was reminded of its smallness. Online, September has become a shorthand for fragility, for the uncanny clustering of danger and wonder. Even in scientific circles where precision rules, there is an acknowledgement that September felt different, that it was more than a set of unrelated events. Science and myth are not always at odds. Sometimes they walk side by side, each expressing the same awe in different languages. And yet, beyond the myth, the science itself carried seeds of transformation. The data gathered from September is still being passed, still producing new insights into asteroid orbits, cometary structures, and interstellar composition. FA22 may have been small, but its near miss underscored the urgency of expanding sky surveys. Swan's disintegration provided new models of how fragile comets behave under solar stress. Apophis reignited planetary defense planning, focusing attention on future flybys. And Atlas was a gift of alien chemistry, a laboratory in the sky, a chance to glimpse material formed beyond our star. Each of these threads will lead to discoveries that ripple out across years, perhaps decades. September was not just drama, it was data, and data will continue to shape our understanding long after the headlines fade. But perhaps the deepest transformation lies not in science or myth, but in perspective. September forced us to confront the contradiction at the heart of existence. We are simultaneously insignificant and miraculous. Insignificant, because in the scale of the cosmos we are fragile, temporary, one accident away from erasure. Miraculous because against that backdrop, life exists here at all. Life that can notice, can think, can tell stories. September was a reminder that fragility is not failure but truth, and truth is the foundation of resilience. To admit we are vulnerable is not to surrender, it is to prepare, to unite, to act. In the months following, conversations began to shift. Governments held meetings about planetary defense budgets. Space agencies discussed faster survey telescopes, more powerful deflection missions. Citizens debated humanity's role in the cosmos, not just as survivors but as explorers, as stewards of a fragile world. These conversations are ongoing, unfinished, but September gave them urgency, gave them weight. It is easy to ignore the sky when it is calm. It is impossible when it rages. The memory of September ensures that the sky will not be ignored again, at least not so easily. And yet for all the policy and science, the lingering effect may be more personal. Individuals who watch the events unfold often describe feeling smaller, but also more connected. Smaller, because the cosmos dwarfs us. Connected, because in that vastness we are together, sharing the same vulnerable planet beneath the same unpredictable sky. When FA22 brushed past, it was not just one nation it might have struck, but all of us. When Atlas passed through, it was not just one set of eyes that watched, but millions around the world. The sky erases borders, erases divisions. September reminded us of that truth, even if only for a moment. Perhaps the greatest tragedy would be to forget it again. There are, of course, questions that remain unanswered. Was September truly unusual, or was it only our perception that gave it shape? Will we see another month like it, or was it a once-in-a-generation cluster? What else is out there, unseen, waiting to arrive? These questions hang in the air, unresolved. But perhaps resolution is not what matters. Perhaps what matters is that the questions exist at all, that we are asking them, that we are looking up. The universe will not give us final answers, but it will give us endless opportunities to wonder. That too is survival. That too is meaning. And so, section 14 is not really an ending, but a continuation of the same thought, stretched further, deeper, into the marrow of what it means to be human in a cosmos that does not bend to us. September has passed, but its echoes remain in science, in myth, in policy, in memory. The asteroids are still out there, the comets are still crumbling, the interstellar travelers are still drifting, unseen, and we are still here, fragile but awake, small but aware, uncertain but determined. That is the legacy of September. That is the truth it left us with. Perhaps one day, centuries from now, September 2025 will be remembered as a turning point, not because disaster struck, but because disaster almost struck and because the near misses and mysteries together forced us to change. Or perhaps it will fade into history, one month among millions, remembered only in data tables and obscure records. Either way, its meaning now is undeniable. It is the reminder we needed, the perspective we lacked, the story we will tell for years to come. And as we tell it, as we turn it into memory and myth, the sky waits. It always waits, quiet now, but not forever. The universe will write the next chapter in fire or in silence, in danger or in beauty. Our task is not to predict the ending. Our task is to be ready when it comes. That is what September taught us. That is what remains. The story of September was never about endings. It was about beginnings. beginnings of questions, of awareness, of perspective. When the skies erupted with asteroids, comets, and a wandering interstellar fragment, it could have been dismissed as coincidence, as mere chance in the vast unfolding of the cosmos. But for those who watched, who listened, who felt the shiver of smallness under the night sky, it became something more. It became a reminder that life on this fragile planet is not guaranteed, that survival is not passive, and that meaning is something we carve against the silence of a universe that does not explain itself. September's events revealed our vulnerability, but they also revealed our strength. Fragility does not diminish us, it defines us. For if we were invincible, there would be no urgency, no need to prepare, no reason to wonder. It is because we are breakable that our existence matters, because we are temporary that our choices carry weight. Each asteroid that missed us, each comet that fell apart, each alien rock that drifted through was a symbol of that paradox, the thinness of the thread we hang by, and the miracle that we hang on at all. And what do we do with that knowledge? That is the real question September left behind. Do we retreat into fear, paralyzed by the reminder of how easily everything could end? Or do we step forward with eyes open, determined to prepare, to explore, to endure? To look up at the sky is to tager, yes, but also possibility. The same cosmos that flings rocks across the void also forged the stars, the planets, and the very elements of our bodies. It is both threat and gift, destroyer and creator, indifferent yet wondrous. To live within it is not to seek safety, but to seek meaning in the brief light we are given. The conclusion, then, is not an answer, but a choice. A choice to see fragility not as weakness, but as clarity. A choice to see coincidence not as randomness, but as reminder. A choice to treat September not as a fluke of celestial mechanics, but as a lesson in humility, preparation, and awe. For the universe will not slow for us, it will not explain itself, it will continue as it always has, silent, vast, unending. Our only task is to decide how we meet it, and perhaps that is the greatest gift September gave: perspective. It forced us to look beyond ourselves, to see the world not as permanent but as precious, not as central but as fleeting. It asked us to imagine a future where we endure not by ignoring the sky but by embracing it, by building defenses, by expanding outward, by turning fragility into resilience. It asked us to imagine that even in a universe indifferent to our survival, our awareness, our wonder, our stories still matter. So as the memory of that month fades into the background noise of history, let it not be forgotten as a time of fear, but remembered as a time of awakening. The asteroids will come again, the comets will crumble again, the interstellar visitors will pass again, but so will we, watching, wondering, preparing, enduring. September did not end the story. It simply reminded us that the story is still being written and that we are part of it.